We are continuing with MySQL, how to create database and create table in those databases. So today the project, we want to take a particular project. The last time we treated bank customer database and university database. So today we want to look at a database that we a hospital management database. That is the database we are looking at today. Health patients analysis project. We are analyzing. Alright, so we want to analyze patients' demographies. The treatment outcome are identify common health trends, assess effective treatment, and improve patients' care. So to design this data, we have to design a database and create tables. We create this tables. We have patient table, appointment table, diagnosis table, and treatment table. So that is what we need to create. So if we go to MySQL, here is the query tab that we'll be using. I already type the data, all the tables that we need. Because of time, we cannot be typing in now. I'll just be creating strange to them. You can get familiar with it. All those things, they introduce this concept of databases to me in this MySQL during my IT. When I was doing IT, it was strange to me too. I did not even pay attention to it. I just ignore it. This one that I'm teaching you now, I have to learn it later on, because when I came to understand the importance, that time I would just fill my logbook, and so that I will just score. I'll get the scores for my sideways and then go away. I didn't pay attention because it was strange. I was coming from, my first degree was in mathematics, so I did not necessary. I did not see the necessity of studying databases and all of that. But as life goes on, I came to study all those things on my own, just as you are studying them now. This is not your formal study in your education curriculum. So we to create the hospital base, we create a database and call it hospital database. So usually whenever you are creating any line of code, you end it with this semicolon. So that is what you should put in your mind always. So we are creating a database, and we call it hospital database. That is hospital DB. So we now run it, and it has been created. So the next thing is to use the database. We have created the hospital database. Now we want to use the hospital database. So you come to this next line, and then you run it. If you run this, now we can use the database. We can now create tables inside the database called hospital database. So to do that, we come here, we have the first table we want to create is a patient's table, a table that contains the information about the patients. So we have patient ID, so that is your hospital number. Each patient is assigned a number that can be used to identify such a patient, and then the patient name, first name, last name, then gender, whether it's a male or female patient. When you have options in MySQL, you use this enumerate. This means stand for enumerate. So gender, now we are enumerating whether it's a male or female, and then we take the blood group, we take the genotype, the date of birth, the address, the phone number, and the email address. So let's create this table. Now we come here and we create the table. So the table is created. Here the patient ID is auto increment. So if the first patient ID is 1, the next one will automatically be 2, and it is primary key. Each patient should have their unique hospital number. You cannot assign one number to 2 patients, or you cannot assign 2 numbers to 1 patient. So then the next table is appointment table. So after, when you have a patient, after taking their biodata, you now schedule an appointment with them to see the doctor. So inside the appointment table, we have hello. I'm in class. So sorry for that interruption. um I have the you come to file here to create a new tab. You come to file and come to new query tab. You create. So we come here, let me press the code here. So let's change that table. Now we call it patient database instead of hospital database. Let me use it as, or let's create a database and call it clinic database. Clinic. Database. So we create the clinic database, we run it here, it is created. So we now use it, use clinic database, use clinic database. We run this, it has run. So now we now create the table called patients inside the clinic table database. So we create this table. The table is created. I hope people are with me. Can you both see what I'm doing? Are you seeing my screen? Can you hear me? Hello?
Yes, we can hear you.
Patient database. ID update bring patient table. This table now when we are still D or is this then we find the foreign key. So let's run this. So this table is also now created. Another table we want to create now is the treatment table, the table that gives record of all the treatments that we carry out on the patients. So we have treatment ID, the patient ID, the diagnosis ID. Here patient ID and diagnosis ID, they are foreign keys, two of them. Then we have treatment date, treatment start date, which day they started the treatment, and treatment end date. Then we have treatment description, then the outcome. Is there any improvement, is there no improvement, or is the treatment going on? These are the outcome that we expect. Then we define the foreign key, the patient ID and the diagnosis ID. So we create the table. We create the table now. The table is created. So now we have created 4 tables so far. We will now want to insert values into those tables. The first table is a patient's table. Let's now input random values into the table. By the way, now we are creating this is a development stage. So but in real life, if after you have created a database like this and it is now deployed to a particular hospital, automatically when a patient comes in and they take the patient's data, it will be updating itself. It's not something that you will be inputting the values. So now if a patient comes in, you now take the biodata of the patient, the name, the date of birth, all of that. Automatically when you save it, it will now update. So next time when the patient comes, what you will require to do is to query the database to get the patients. Like most hospitals now, like even here in Katsina, in Federal Medical Center, all they do is computer based. If you go to the hospital and you go to record section, you give them your hospital number. From there they query your details. They now forward your detail to the nurses section. The nurses will now take your temperature, your blood pressure, your weight, and so on, and then now forward all this one. Those in the record section, they are not going out to nurses section. They will send it electronically. The nurses will now send it electronically to the doctors. They will now assign you which of the doctors to see you. After the doctor sees you, they will now prescribe the treatment, whether you are to carry out a test or they will just prescribe some drugs for you. Then now we send you to pharmacy. When you go to the pharmacy will see the record that has been sent from the doctor, and they now give you drugs. So that is how it is done. So these are the this is the technology behind all this. If you go to such a place and you see all those things happening, this is the technology behind it. So some people were complaining the other day that they never expected things like this. These are things that if you want to be a data analyst, you will know. Because if you apply for a data analysis job, these are the things, some of the things they will be asking you. And when they ask you and you know them, that means you are not ready for data analysis yet. So now let's insert values into the table now. So the first one here we have Ogadomi, and it's a male, and the date of birth. First of all, we are inserting value into the patient's table. You call the name of the table, which is patients, and then we have this column: first name, last name, gender, date of birth, address, phone number, as was defined. You cannot insert a value that was not defined in the table. All the values you are putting here must be the one that were defined when the table was created. So we now the first name is Oga, last name is Domi, gender is male, date of birth is 1985, April April 1985. And then the address is number 23 Agadu Street. This is a phone number. This is a email address. When you want to enter another value, you put a comma, and then you put another patient here with all the details. You put this one, you put this one. When you finish putting, then you put a semicolon. You put a semicolon at the end, because you put comma, comma, comma. Now you put in a semicolon. In MySQL, semicolon is similar to full stop in real life English. So when you put a semicolon, you are telling it that you have stopped that line of code. So you now run this. We come here now and run the code. So it has effected successfully. So if you want to see this table, if you want to be sure of what you do, you can now say select from. You can say select all from the name of the table is patients. Select from patients. And then you run it. So it is fetching the data we have. So this is a table here. So we have patient ID, first name. We did not include the patient ID here because it was defined to be auto increment. When you define it to be auto increment, you don't need to be putting it manually. Automatically the patient ID will be generated. So the first patient is patient ID 1, the first name. This is the value. This is the data that we enter. So as patients keep coming, as you are updating the patients, that is how they will keep updating. Here now we did not input the value of, they will not include the blood group and genotype. Maybe the patient did not carry out tests to determine the patient blood group and genotype. But later on, when you get that value, you can update the table. So that is that. So the next thing is we now want to insert value into the appointment table. So in the appointment table, we have patient ID, appointment date, doctor's name, reason for the visit, and then we put these values. This is how you insert. You say insert into the table those columns and these values. This is how you define it, and then you input. Here now, this is a patient ID 1. This is a date that was appointed for the patient to see the doctor. The name of the doctor is Dr. Brown, and the reason for the visit is a routine checkup. The second patient is a patient ID 2, and the reason is that he observed flu symptoms, and the doctor that is going to see him is Dr. Green, and this and so on and so forth. So we can run this table. We run this table, and it is successful. So the next one is we insert value into the diagnosis table. Insert into diagnosis the patient ID, the diagnosis date, the diagnosis description, and the severity of the case. So we have this value. Patient 1 was diagnosed on the same day that he saw the doctor, and the description is that he has hypertension. And is this severe? It is moderate. this patient 2 was on this date, and the reason is that he has influenza, and is it severe? It is mild, not severe. This patient 3 has eye defect, and it is moderate case. And then they say this other patient, this one here now is the same patient here. This patient visited on the 3rd with influenza, and then visited again on the 12th with a malaria case. And at this time it was a severe malaria case. Maybe the influenza now triggered malaria in the patient, and the patient has to come again. So if we run this, we run this, and it is successful. So the next table is a treatment table, the table that keep record of all the treatments carried out in the hospital. So we insert into the treatment table the patient ID, the diagnosis ID, the transaction, the treatment date, which day they started the treatment and which day the treatment ended, and the description, the treatment description. Is there any improvement? So we have these values here. So let us run it. And this is also okay. So now that we have created those tables and we have inserted values in them, the hospital now may want to do some analysis. They want to know certain things. They may want to know the total number of cases they have. So because in a day they will just be, as patients are coming, they are attending to them like that randomly. So maybe at the end of the month they want to carry out how in total how many patients were attended to, and those patients that were attended to, how many of them had severe cases, how many of them there is improvement, and so on, which doctor attended to which to them. You may be interested to know, because so that a particular doctor will not be overburdened of having multiple appointment with patients. So those are the things that can be analyzed by you, the data analyst working in such a hospital. So, or maybe you are working with an NGO that is responsible for health improvements of the public. So those are the things they will expect you. So the first thing is, now we want to select diagnosis description. This diagnosis description is a column under diagnosis table, and then we want to count from diagnosis. So this is how, if you want to select a particular column in a table, this is how you state it. You say state, you select, then you state the name of that column, and in this case we are counting all. This star here mean all in MySQL. Wherever you see this sign, we're talking about all. Here now you count all as count from the diagnosis table, and group by diagnosis description, and then order by descent. This mean descending order. We want to treat it by descending order. So let's run this. So you run the table. So this is the table now. Here now, all of them, they are one, because we did not put much data in the table. If you have many cases, so this analysis you have done here now will give you the count of the cases with highest number down to the cases with lowest number. That is what we mean by This mean descending order. You are counting in descending order, but here we just put 4 values for demonstration purposes, and each of the cases has only one count. So the person with hypertension has one, the one with influenza one, the one with eye defect has one, the one with malaria also has one. So but if we, in a real situation where you have thousands of cases, if we run this code, it will now give you the cases with highest number of occurrence, with highest count. How, which is it hypertension that has high number of cases, or is it eye defect, is it malaria, is it influenza, is it HIV, or whatever the cases that you have. So that is how you can count, you can run count in a table. So another analysis we can do is that we can take the average age of the patients. Those patients that have been attended to, what is their average age? So to do that, you select from diagnosis description. This D here, this is another way of selecting. This D is standing from diagnosis table. D, so you say select D dot diagnosis description. Diagnosis description is another column. It's also a column under diagnosis table. And then you now say AVG. AVG stands for the average. And then you take the year and the current date minus the year dot P dot date of birth as the average. So here P is a patient. You are now taking date of birth from patient's table. This is a short way of referring to patient table. You say P dot date of birth. So from date of birth you are recording the date of birth. From patient table you are recording the date of birth, and you want to take the average age. So from diagnosis table D, you are going to join the patient table on the date of birth. You are going to join the patient table with the diagnosis table, and it's not everything in the patient table and the diagnosis table that you are joining. What you are joining is only the patient ID. The patient ID is what you are interested in, that patient table. And then the patient, from diagnosis table you take the patient ID, and from P here means what? From patient table you also take the, because the same patient ID in the patient table is the same patient ID in the diagnosis table, and that is what they mean by foreign key. So you are now joining this, and then you group it by diagnosis description. So it will now bring out the each patient ID and the description of the test that was carried out. So if we run this thing, let's run it and see. We now run this. So you can see here now, this is diagnosis description, and this is the average age. So in this case here also, it's only one cases we have. So under hypertension is only one person, and the average the age is 39. So but if you have many cases of hypertension, it will now give you the average age of those with hypertension. It will also give you the average age of those with influenza, the average age of those with eye defect, the average age of those with malaria cases. So we can also do another analysis. We want to know the success rate. Those patients that were diagnosed with various cases and treatment was applied on them. Is there any success? So there is success when there is improvement. But if there is no improvement, that means there is no success. So to do that, you will select diagnosis from description. You select diagnosis description. You want to count the cases where the outcome is equal to improved. If the outcome is improved, then it will return 1. But if it is not improved, then it will return null. Then times 100 divided by the total number of counts. That would be your success rate. The success rate is the total number of cases that have improved divided by the total cases that we considered. If you have 20 patients that were attended to and 5 of them, there's improvement in 5 of them, then the success rate is going to be 5 divided by 20 times 100. This is what this thing means here. This code, that is what it is saying. So you are selecting the diagnosis description from the treatment table, and the case you are considering is where there is improvement, case where the outcome is equal to improved, because from the table that we defined under, let me go there so that we see, under treatment table here, we have the description, the treatment description as either improved or there is no improvement. It's not here. Where do we define? And this is where we defined, we created a treatment table. Look at this. We say the outcome is either improved, not improved, or it is still going on. So here now we want to know the success rate. How many of the patients has received improvement from the treatment given. So the treatment success rate, we are now saying select the diagnosis description, counting the case where the outcome is improved. Where the outcome is improved, then we have 1. Otherwise, it will return null. Then we multiply it by 100, divide by the total number of counts, and that will be our success rate. So, and this is taken from the treatment table, and we're also joining it on the diagnosis table. We are joining the treatment table, joining the diagnosis ID from the treatment table with the diagnosis ID from the diagnosis table, because it's the same ID. It's the same ID that we have in the treatment table that is also in the diagnosis table. It's a foreign key. The diagnosis ID in the treatment table was in the diagnosis table is a primary key, while the treatment table is a foreign key. So you group it by diagnosis description, and if we run this, we will also be able to see the results. So this is the result. So in this case, since we have only one patient in each of the category, and all of them we enter as improved, then the success rate is 100, because we have only one patient in each category, and each of them there is improvement. So the success rate is 100. If there are 2 and one is improved, other one is not improved, then the success rate will be 50. So this is a demonstration process. In a real life situation, I'm always giving you that. In a real life situation, like here in Katsina, I'm giving you example based on experience. Here in Katsina, we have 3 major public hospitals. We have Federal Medical Center, we have General Hospital, and we have Ture Yaradua Hospital, where they treat children and women. I think in this in this platform I announced to you the other time that my son was not feeling fine. I'm sorry I did not even give you the feedback. It was this week on Tuesday. Okay, not today is Tuesday. Last week Thursday, they carry out the surgery on him. And if you go to that hospital, you see you see many people coming, children and women. So if you go to real life situation, you see a lot of so as you as analyst in such a hospital, you will have a lot of data to work on, not this one that we are demonstrating here, that we just have single cases. But in a day in those hospitals, you see 100 cases of a particular case of a particular item. Like my son was operated of hernia, so that hernia only you will see multiple patients. If you go to those women under what do they call it, pregnant, those women that are pregnant, what do they call this thing? You see multiple, you see a lot of them. So a hospital that is serious, that sometimes they don't take things serious in countries that are all these things, why they are taking the data, you don't just take data for taking sake. After you take the data, you analyze the data so that you see the area that needs improvement, and so on and so forth. So here now the success rate is this. Another thing we can do is we can also take the total appointment by doctor. We want to know each of the doctor how many appointments they have. Maybe you are making this analysis for a whole year, or it is for a month, and you want to know within that time on our study, the doctors working, how many appointments they had with the patients. So it will now help you to see whether the doctors are being overworked or are they underworked, or and so on and so forth. So that as the management or those in decision making, they will know the best decision to take, either to improve or to maintain the tempo that is there. So to know the total appointment by doctor, you select doctor name and then count it as total appointment from the appointment table. You are selecting the doctor name from appointment table, and then you group by doctor name, so that it will bring out the name of the doctor and the number of times the doctors attended to the patients. So if we run this thing here, it now gives us each of them attended to one patients. Dr. Brown attended to one patient, Dr. based on the data we entered. Then we can also select a patient with multiple diagnoses. We want to know among the patient, is there any patient that has more than one case? So let's run it. In from the what we got that time, I saw that one of the patients was attended to more than once. Yes, so if we run this, we can see that Jane Otumba had 2 diagnoses. So in a situation where you have you have large number of patients, you can see that some patients will be attended to for more than once within that time frame that you are considering. So that is how you can run such analysis. You can create a table if you are employed as a database administrator in a hospital. So these are use cases. In the introduction of this class, I mentioned of having domain expertise, domain knowledge. You must not be a doctor or a medical practitioner for you to understand what is going on in the health in the hospital system. So as a data analyst, this is what you can do. You create a database that we keep the record of all the patients in the hospital. We keep create another table. Okay, inside the database you now create table that keep record of patients with their personal information, the day of appointments, the type of treatment, the type of diagnosis, the treatment, whether there is success in the treatment, and then you carry out this analysis from time to time to give report, to give a report to the hospital management for better welfare of the patients and even the staff working there. So at this juncture I will open room for questions so that we know the head, we will know where we are heading to, whether someone is getting something or people are getting more confused. So if you have a question, please can you raise your hand up?
Yes, sir. I just come along, sir.
All right, you're welcome. Okay. Somewhere now. So,
Yes, sir.
all right.
Can you hear me, sir?
Yes, very well. I can hear you.
Okay, my question is, while we're creating this database,
Hmm.
do we have to insert those values, or we just need to create the model and
Yes, we are.
leave it for
Yes, we are inserting the value here for the purpose of learning.
yes, for the purpose of learning. Okay,
Yes.
but while we're creating we don't need to. We just need to create the model and leave it like
Yes,
that.
you just create a template, and as patients are
O-
coming, they will be populating the patients as they are coming in.
Okay, it will be updating automatically as they are doing it.
Yes, as like this patient registered with the hospital today, his or her information will now be updated in the database.
Okay, ours is to create the database and then create the templates, and that's all.
Yes, yes, and the operators, those that are operating as they are those in the record section, as the patient come and
Yes.
register, they put everything and update it. So that is how it will. So but you there will be there as a database administrator to be managing the database,
Okay.
to be updating the database. Maybe there is a need for you to create additional table. So
Additional table or additional columns.
yes, additional columns in a particular table, or to delete a particular section, and so on and so forth. So that will be your work as a database administrator.
Okay, sir. Thank you, sir.
You are welcome.
Hello, sir. Hello.
Yes, Emmanuel, Samuel Emmanuel.
Hello, sir. Good evening, sir.
Hello.
Hello, sir.
Yes, I can hear you
Can you hear me, sir?
very well.
Okay, sir. Sir, good evening, sir.
Good
Well done,
evening.
sir.
Good
Thank you
evening.
for the lecture, sir. Good evening.
All right.
Yes, sir. Sir, I was in that area. I was a little bit confused in the area where you were joining the D dot description and the D dot patient table. That primary keys.
Okay.
where I was a bit confused in that area. I
Okay.
I really don't know if you said we can, if we see the D dot can be replaced as description, and those places we have P dot or T dot table can be placed. So why are we still putting the D dot or T dot before the table and we are still referring to table? Can't we as well write the T dot DB and still get the same results?
Can we still write as what?
Description, patient description.
So here
Yes,
now you
sir.
are looking, you are selecting from two tables. From diagnosis, you are selecting from the D is diagnosis table, and the column you are selecting is diagnosis description. Are you
Okay,
following?
diagnostic description table.
No, diagnosis
Okay,
description
the
is a
D is
D is a diagnosis table, and the diagnosis description is a column in that table.
okay. Okay, sir.
Do you understand? This
Okay,
diagnosis
sir. I get it
description is a column
now.
in
I
a table.
understand, sir.
So here now you
Okay.
have D dot patient ID. So you are selecting the patient ID. The patient ID is a column in the in the in the in the diagnosis table. And this other one now is P dot patient ID. You are now selecting the patient ID from the patient table. Is that all?
Okay, sir.
Do you
Okay,
understand?
sir. I understand, sir. Sir, in other cases, I was trying to follow you, but today's lecture was so comprehensive that you were fast enough that we cannot follow you. So I
Today I
noticed
was
on
fast.
my yes,
Yeah.
you were very fast, and now it has to take us that cannot assimilate to follow you gradually. So,
Yeah.
sir, I noticed if I try to execute this thing is not actually highlighted. My execution, this thing, I could not when I create
No,
a
you have to
database.
click your mouse where you end that line of code.
Yes, sir.
Can you see here?
I noticed when I clicked the mouse there, when I click on the execution,
Uh,
I click on the execution, I noticed the action output is not giving me just giving me time action. It's not giving me as it was before. I don't know
uh.
what has happened on it, sir.
No, sometimes those things, even me, you can notice that the first time I started running, something happened. I didn't even really know what happened. I had to go and copy the code because I already work on the code somewhere. So I copy it and come and replace and started working. This was where I started working. This look at it now, something it just went blank. I have to go and sit down to understand what really happened. You can see it here. This is
Okay,
where I
sir.
started to show the class. But so I
Yes, sir.
don't know where I pressed that the whole thing went blank like this. So I went to copy the code where I work on it before to come and paste here and started explaining back. So maybe
Okay,
we will
sir.
look at that at the end of the class.
All right, sir.
Thank you.
Okay, sir. So we hope the record will still be placed for us to
Yes,
see so that we can
I'm
have it.
still record. Even the questions that we're asking, the recording is still going. I will send it to you people.
Sir.
Mm. Any any other question, please?
Okay, sir. No, no, no. Thank you for now, sir.
Uh, Ogunwale Michael.
Yes, sir. Good evening, sir.
Good evening, Michael.
Hello, sir. Yes, sir. Where you were explaining that of average, where you said when we have something, we have one. When we have something, we have none. I
Mm.
didn't really catch up with that area.
Okay, from there now, in one of the tables, under what do we call it? Under whether where we wanted to calculate the success rate. You know, there is sources when a patient is treated and right. So there's an improvement or no improvement, or the treatment is going on, that you cannot determine whether there is improvement or not yet. So on that day you now said when you say count case when outcome, this outcome is a table, is a column rather. This outcome is a column. So you are now counting the cases where the outcome is improved, and when the outcome is improved, then you say it should be 1. That one is saying that there's improvement. Where there's no improvement, then it will return null, because it is that one that is standing for improvement. It's a kind of boolean type of data, where it is yes, whether it is true or false, or if it is switch, you switch on or you switch off. It's a kind of that. It is something like that. So when it is 1, then you now have a success rate. Otherwise it will be null. You have not recorded a success yet. That is what it means. So to know to know the total success rate is the cases where you have a success multiplied by 100 times the divided by the total number of cases. So look at it. This is where we did that, and we got the success rate to be 100 for each of them, because we had only 4 cases and each of them there was improvement. I don't know whether I've answered you, Mr.
Yes,
Michael.
sir. Yes, sir. Thanks so much, sir.
All right.
Yeah, yes. Thank you so much, sir.
You're welcome. Any other person? Suleiman, anything? Yahya Jimo. All right. If there's no this thing, I would. Somebody said that I rush, so I will not go for that. I will stop the class here. You practice, go over it, practice on your own. Make sure you are following. Make sure you are having. You can get more projects. The last class I introduced you to use of AI, so you can practice this that I've given you, and you can also go ahead and ask AI. You can go to your ChatGPT and say, give me a project, give me data analysis project that I can implement in my SQL. That is the instruction you can give it to AI. You can say, give me data analysis projects that I can implement in my SQL. Now it will list a list of data analysis projects for you, and then
Analysis projects for you. And then you
what is that?
what is that?
So you now select one of them
So
that
you
you
now
want,
select one of them that you want,
and then you ask it to help you
and then you
implement
ask it to help you implement it.
It will now bring out all the necessary
We now
code
bring
that
out
you
all
need.
the necessary
So you can this particular code.
code. You can reach out to.
I don't know what this is.
I don't know what this is. Is it let me in the classroom?
All right, thank you. I have
All right, thank you.
a
I
night
have
rest.
a night rest.
Thank you, sir.
Thank you, sir.
Welcome.
Welcome.
Thank you, sir.
Thank you,
Thank you, sir.
Thank you, sir.
Good night.
Good night.
Good night.
Good night.
Oh, yes.